Guys, we're back with the notes for 7.1. These should be the notes that you are watching as soon as you finish your Unit 6 test, okay? So there's a 7.1 Explore that hopefully you're playing around with a calculator and kind of refreshing this in your brain because it's been a minute since we've graphed. But a lot of this should be all back from transformations that we learned in Unit 1 when it came to the square root function and the cube root function, okay? All right, so the first thing we're going to do is graph each of these, and then we're going to give the domain and range once we get them all set, okay? All right, so when it comes to square rooting x, I want to remind yourself that you cannot square root a negative, okay? So we would call that like DNE, like does not exist. You can't square root that, okay? So if we think about all the negative numbers, I'm just going to say square root of negatives. I'm going to put DNE. Remember that we cannot square root a negative. So the first point that we're going to set up on our table is going to be 0. Okay? Square root of 0 is 0. So that's my y. Square root of 1 is 1. So our next point is 1, 1. Now, when you start getting to the square root of 2, that's a decimal. Square root of 3, that's a decimal. So if you recall back from Unit 1, square root 4 comes out to be a whole number. It's the whole number 2. That was our next what we call a critical point, or the main points we put on a graph. Think about the next number you could square root. That would be a 9, right? Square root of 9 gives you 3. So 9, 3 would be the next point. Okay? Let's take just a second. We're going to go ahead and graph those on our screen. So 0, 0, 1, 1, 4, 2. And I know 9, 3 doesn't fit, but I am going to make it fit just so you know that he is the last critical point. Okay. All right, we are going to give all domain and range for these notes in interval notation. Remind yourself, if you are ever going to an infinity or a negative infinity, we use parentheses. If you are including a point, we would use a bracket. Okay? All right, so if I'm looking at this graph, going for my x's, the first x I can use is a 0. I do include him. And I go all the way to the right forever, that's positive infinity, okay? So I'm starting on the left at 0, going to the right forever. When it comes to range, I'm starting at 0, and I'm going up forever. So I would say from 0 to, again, positive infinity. I'm including the brackets on the zeros, okay? You will include the bracket on all of these unless you were to have a less than, greater than situation. Those are when we would use parentheses again for inequalities. Okay, if you need to pause the screen, write what you see, that's great. Otherwise, we're moving to the bottom. Okay, for each of these 4 graphs, I'm going to give the transformations for them also on top or to the side of them as a way to refresh your brain as we go through these, okay? All right, so remember your transformation codes. Let me write this right here in case you have forgotten. For square roots would be A, square root B, x minus c, and then on the outside, plus d. Remember, if you see something like this, we have to get the b out of there and leave it as x minus c in order for the c to tell us if we're going left or right, okay? So A controls our vertical. Remember, we are either a vertical stretch or vertical compression, depending on if it's large or small. If this is negative, it's a reflection over the x, okay? Second thing, my B is either a horizontal compression or a horizontal stretch, depending on what number it is. And if it was negative, that's a reflection over the y-axis. C moves us left and right, but it's backwards of what you think. Negatives go to the right, positives go left. D is my up and down. He follows the rules. Positives go up, negatives go down. Okay, if you want to write that on your paper just as a way to refresh your brain, that's a good plan. We're going to put the transformations for each problem out to the side. Okay, I'm going to switch to blue real quick. All right, so problem 2, the only thing that I have is a negative out front. So that is a reflection over the x-axis. Basically, instead of my graph going this way, he's going to flip down and go this way. Okay, all my numbers are still going to be the same, but the y's are just going to be negative. So if you would like to go up to your table, I'm going to go 0, 0, 1, negative 1, 4, negative 2, 9, negative 3. Okay. So I'm going to graph those few points that I can fit real quick. And we're going to let the 9, -3 stay off of the graph from now on. Make sure that means right here that you do not ever cross over this -3 line. Your graph should approach it, but it would not technically hit until out here. So you should not hit the -3 line. Okay. All right, let's talk about number 3's transformations. He's got a negative out front. That's a reflection over the x-axis. He's got a 2 out front, which is a vertical stretch. Vertical stretch by 2. He's got a -1 in the parentheses, which is going to move us to the right 1. And he's got a +1 after the square root, or after the parentheses, which is going to move us up 1. Okay? So if I'm going right 1 and up 1, that means my new vertex is at 1, 1. Okay? My normal pattern, if I can zoom in real quick, my normal pattern would be to go out 1 and up 1, but this one is a vertical stretch by 2. So when I go out 1, instead of going up 1, I'm going to go up twice as far. Okay? Normally my pattern is out 4, up 2, but I'm going to go up twice as far. So I'm going to go up 4 right there. So you should have points at 1, 1, 2, 3, and 5, 5. There you go. That's your graph. Problem number 4, I have a 3 out front. Again, that's a vertical stretch by 3. I have a +1 under the square root, which means I'm going to go left 1. So I don't go up or down at all. My vertex or my starting point is just going to go left 1 space. And we're going to follow that same stretch again. So if I zoom in, normally I would go out 1, up 1, but I'm going up 3 times as far. Normally I would go out 4, up 2, but now I'm going up 3 times as far. Okay, so if these goes away, this is my graph. You should have points at -1, 0, 0, 3, and 3, 6. Perfect. Last one of these. We're going to use that 2 out front again as a vertical stretch by 2. A 2 under the square root is going to take us left 2. And a 3 outside this parentheses or outside the square root is going to take us up 3. So my new vertex or starting point is going to be left 2, up 3. That is right here. And we're going to follow that stretch situation one more time. So normally out 1, up 1. We're going to go up twice as far. Normally out 4, up 2. We're going to go up twice as far. This is your graph. You should have points at -2, 3, at -1, 5, and at 2, 7. All right, I'm going to pause the screen for just a second in case you need to copy any of those graphs to get them exact, and then let's talk domain and range. Perfect. Okay, so looking at domain, remember we're going from left to right. So if I look at problem 2, my graph from left to right is going from 0, where the starting point is, to the right forever. My range this time is starting at 0, but it's going down. So that means we're coming from -infinity. We're going up to 0 before we stop. So range goes from down, comma, to up. Okay, so that one's backwards. Problem number 3. We are going from left to right. So we started at 1. That's where my starting point is. And I go right forever. For the range, we're starting at 1 for the y, going up forever again. So 1 to infinity. All right. Problem number 4. We started at -1 over here. So we're going from -1 on the left to forever, infinity on the right. For the y's, we started at 0, going down, and we're going up forever to infinity. Last one of these, number 5. We started over here at -2. So from -2 on the left over to infinity on the right. We're going from down to up. So we started on 3. That's my lowest y. So I started at 3, and I go up to infinity. I'm going to pause the screen one more time. If you need to copy down anything on this first page, go ahead and do that. Otherwise, we're flipping to the back. Perfect. All right, so on the back, the difference is we're doing cube roots. Remember, cube roots, you can cube root a negative. Okay, so I'm going to zoom in real quick. We definitely want our 0, 0 in the middle, because if I cube root a 0, I get 0. But since I can do negatives, let's think about what the cube root of a -1 is. What could I multiply by itself 3 times to get a -1? Well, that would be -1, because I would do -1 times -1 times -1 gives me what I want. Okay? Now, we're obviously not going to be able to cube root a -2, because that's going to give us a decimal. There's no numbers that would do that. Same thing with cube rooting a -4. It doesn't work the same as a square root does. The next one that I can do a cube root of is going to be my 8s. Okay? So we would end up with -8, and then same thing going the other way. We can cube root a +1, cube root a +8. What would the cube root of 8 be? What times itself 3 times gives us 8? Well, it's my next constant. It's going to be 2 times 2 is 4, times 2 is 8. So we get a 2 and a -2. Let's put those all into the table. And then we should be ready to graph. If you want to pause, write any of that down, you're welcome to. It's still going to be on the screen. Let's graph that parent function real quick. So when I graph those, it's going to look something like this. I know that's really sloppy, but it's going to look something like that. Zooming in, we should end up with 0, 0, 1, 1, and then all the way over to 8, 2. Okay, very last one on the screen. Same thing. Left 1, down 1, -1, -1. And then left 8 down 2. That's -8, -2. Be careful when you do this. If I see this on a quiz where it looks like, you cut a corner and then you did this and there's kind of like corners here, I am not going to give you credit for that. Okay? It should look kind of like a parabola. It should be curving. So it curves smooth like an S. All right? Pause that for just a second if you need to copy any of those points or table. We're going to move to the bottom. All right, so transformations are going to be the same. We're only doing 3 of these. So I'm going to write the transformations out, do the graph, and then we'll talk domain and range, okay? All right, so on that first one, there's only a negative in front. So again, that's a reflection over the x-axis. That's going to take our graph, and instead of going this way, it's going to flip it and go this way. All right, so that means instead of going 0, 0, and then up 1, right 1, we're going to go the other way. We're going to go down 1, right 1, and up 1, left 1. Our S is just going to shape the other way. We're still going to go right 8, but we're going to go down 2. Still left 8, but now up 2. Make sure this looks like a curve. Okay, there should be no corners here. Perfect. Problem number 8, we have only a 2 in front. That's a vertical stretch by 2. So whatever our normal pattern is, we're going to go up or down twice as far. Our starting point is still at 0, 0. Normally we would go out 1, up 1, but now we're going to go twice as far up. Normally I would go out 8, up 2. Now we're going to go up twice as far, up to 4. So this is my first curve. Let's go the same thing on the other way. Normally left 1, down 1. Now I'm going down twice as far. Normally left 8, down 2. But now I'm going twice as far. So your second curve should come around like this. And get all the little extra pieces out of there. And that should be your graph. So it should just look like it got stretched a little bit. It's just wider and more exaggerated. All right, last one of these. We still have the 2 out front, so we're still doing a vertical stretch by 2. But this time I have a 2 under the square root, that's a left 2. And a -1 after the square root, that's a down 1. So for this one, we have to change our starting position, left 2, down 1. It's going to be right here, and then we follow our pattern. Instead of out 1, up 1, we go twice as far up. Instead of right 8, up 2, we go up twice as far. Let me get that first curved side going. There we go. And get rid of these. All right, going the other way. Instead of left one, down one, we go down twice as far. Instead of left a, whoops, that would be off the graph, so I don't even have to worry about it. So my graph should curve like it was gonna not hit until somewhere out here. Perfect. All right, I'm gonna pause the screen for just a second in case you need to get the graphs before we switch to domain and range. Awesome. There is no domain and range blank on that bottom problem 9 question, so I'm gonna ask that you just put like D and R so that we can still answer those questions, okay? All right, let's talk about number 7. Okay, on number 7, my graph is going forever to the left and forever to the right. That's negative infinity to positive infinity. When it says interval notation, you do not get to say all real numbers, okay? All right, let's talk about range. Range is going down forever right here and up forever right here. That's the exact same thing, negative infinity to positive infinity, okay? What do you notice about these guys? If there's always an arrow going left and always an arrow going to the right, all my domains should be that same negative infinity to positive infinity. Just because I move the location or stretch it, it's not changing anything. Same thing on the range. If it's still shaped like an S and this arrow is still going up and this one's going down, even if I flip it and it starts going this way up and this way down, it's still going to be the same kind of shape. It's still going to go from negative infinity to positive infinity. Okay. Now we are not done with the video. I do need to circle back and hit one more thing, but if you will pause the screen for just a second, copy what you see, and then go back to page 5 with me real quick. Perfect. Okay, on page 5, I kind of skimmed over it, but on problem 5, I hope you noticed that that's not an equal sign, that's an inequality. Okay, so I'm going to erase the numbers real quick so that you can see what I'm talking about. We're actually going to make 2 edits on this. Okay, if I had graphed it with an equal sign, it would have had that blue line. But because I want all of the y's that would be greater than that equation, we have to kind of shift our mind, okay? First of all, this guy doesn't have an equal to under him, which means that when I draw this, it needs to be connected with a dash. So if you would please, if you did it in pen, just kind of make the dashes near it. But if you did it with a pencil, I'm going to ask that you kind of erase little bits and pieces to make this a dashed line, okay? Second thing is we need to understand that we are shading greater than it, so we are shading above it. Let me write that in pink. So greater would mean that we are shading above it. Now, if I can only shade above the points that are on my graph, then that means I can only shade starting from this point. Okay, so I would be shading all of this up here. And obviously, if my graph was bigger, it would continue up here, right? All right, but what happens is now I don't get to include that point -2, 3. So even though we normally include the starting point, because this is not an or equal to, I'm going to have you change this. And we're going to change it to not include that 2 and not include that 3. And that has to do with the fact that because it's a greater than sign instead of an or equal to. Okay? All right, if you need to pause that, copy anything you missed, we are done with the notes for 7.1.